Assalamu alaikum and good morning. My name is Fayad and I'd like to present my conference paper titled High Isolated Thin MIMO Antenna Element for 5G Mobile Applications. Here is the content of my presentation today. MIMO antennas are majorly used to increase the wireless communication system reliability by substantially increasing the data rate without the need to increase the transmitting power or the bandwidth. Therefore, MIMOs are essential in 5G mobile communication to face the data rate hunger as a result of the massive increase in communication devices. Figures 1 and 2 present the configuration of the microwave MIMO systems. So, why the need for MIMO antennas in 5G mobile applications? Well, due to the massive expansion in wireless communication systems, enormous growth of user devices, according to Ericsson Mobility Report, there will be about 29 billion devices by 2022 and around 550 million 5G subscriptions that resulted in severe data traffic and bandwidth scarcity. Therefore, the 5G MIMO antennas are vital to enhance the current cellular network's drawbacks. So what's the real problem? Well, as we already talked, there is a data rate scarcity and a limited space in 5G mobile devices, and that require a compact MIMO antennas to fill in. And the reason is the high mutual coupling that is associated with closely spaced MIMO antennas, significantly degrading the efficiency of the MIMO system and hence decrease the channel capacity. Moreover, the poor validation for 5G MIMO antennas by previous studies and the limitation of the MIMO orders that have been deployed in 5G mobile applications. As we know, the maximum has been reached is 4 and 8, and that's still not exposed to more than that because of the high mutual coupling that will degrade the performance and the poor isolation. Figure 3 displays the mutual coupling mechanism where the transmitted energy of antenna is absorbed by the adjacent antenna, resulting in poor MIMO performance with low channel capacity and poor MIMO diversity. This is the single antenna proposed for the thin MIMO antenna system, as we can see. Figure 4 shows the configuration of the antenna with dimensions of only 13 times 5 millimeters square. The antenna resonates at 3.5 gigahertz, and the configuration has double I-shaped elements at both sides of the inverted U-shaped element, 2 vertical strips, while in the middle has 2 crossed I-shaped elements. L2, L3, and M3 are responsible for tuning the antenna resonant frequency. Figure 5 shows the reflection coefficient at negative 10 dB bandwidth of less than negative 22 dB. The antenna itself acts as an isolating element and a radiating element simultaneously. Figure 6, A and B display the full simulated 16 MIMO antenna system with dimensions of 150 times 75 times 1.6 millimeter cube. The separation distance has been set to only 10 millimeter between the adjacent antenna elements. The MIMO elements are printed on double-side edges of small substrates orthogonal to the system ground, forming an orthogonal mode that enhances the isolation more. So how can we evaluate? this tin MIMO antenna system. What's the most important parameters? Did you know the microwave devices is the scattering parameters? Figure 7 shows the reflection and transmission coefficient of the tin MIMO antenna system. Can be seen that the minimum isolation is significantly shown to be less than negative 19 dB at 3.5 gigahertz, despite the short separation distance and despite the high number of MIMO antennas. Well, the second most important parameter in evaluating the MIMO antenna is the envelope correlation coefficient, or we call it ECC. Figure 8 displays the minimum ECC results between the 16 MIMO antenna elements are less than 0.005, which is less than the maximum limit allowed, which is 0.5, reflecting a significant isolation between the antenna elements. Another performance indicator is the diversity gain. Figure 9 indicates that the diversity gain between the 16 MIMO antenna elements are close to the ideal value. The ideal value is 10 dB at 3.5 gigahertz band, demonstrating high diversity MIMO performance. Another indicator for the MIMO performance is the total active reflection coefficient. Figure 9 indicates that the minimum TARC between the adjacent antenna element of the 16 MIMO system are less than negative 15 dB at 3.5 band, which is less than 0 dB, the TARC MIMO limit, reflecting stable reflection coefficient. Well, channel capacity loss. Most important thing about MIMOs is increasing the channel capacity. However, how much loss the system has already experienced because of the mutual coupling? Figure 9 indicates that the CCL between the 16 adjacent antenna element is less than 0.08 bits per s per hertz per second per hertz at 3.5 gigahertz band, which is less than the maximum limit, which is 0.4 bits per second per hertz, depicting low channel capacity losses. So, how can we know the result is novel, the results are significant? Well, table 2 and 3 confirm the proposed MIMO antenna elements outperform the previous studies, depicting high isolation, more compact size, higher MIMO order, and lower values of ECC, CCL, and TARC. And we know that the lower the ECC, the better the isolation. The lower the CCL, the less losses we have. And also the lower the diversity gain, the higher the MIMO performance diversity. Therefore, it's promising to be deployed in 5G mobile terminals. Well, as we can know that the proposed side-adjacent self-isolated MIMO antenna demonstrate significant isolation, as has been seen in table 2 and 3 compared to the previous studies, and the proposed MIMO antenna system have validated and significantly indicated the mutual coupling effect generated at 3.5 because of the low ECC and the low CCL and the low values of total active reflection coefficient. We can know the MIMO design for 5G in previous studies have been only to 4 or 8 MIMO antenna elements. However, this one is evolved to 10 antenna MIMO elements. However, with better isolation, more compact size, and also higher diversity performance of MIMO system. Therefore, the proposed 10 MIMO antenna elements are significant to be used in 5G mobile applications. If the references have been compared in the literature review, thank you.